Okay, so let's go on ahead with the practical part.
Okay.
So
yeah, let me just show you the practical. So practical is very simple. Okay, and I will explain each and every detail. Okay, so you don't have to worry about it. So this is the only video you have to see for this ESC8 exploitation. Okay. So I have two terminals ready here. Okay. So first I think I have to I think I have to download the tool. So let me just quickly download it. Petit totem. So this is the GitHub repository which you can use. So this is available in binary as well as Python. So we will, since we are using Kali for exploitation, we are going to use Petit totem Python script. Okay. So let me just quickly download it. And then let's go here. wget paste. Okay. So first, as a first step, okay, so first we have to enumerate, correct? So how we can enumerate? Okay. So for enumeration, we are going to use certify tool. So let's use this certify. Let's find, and then let's have some flags. We want to find vulnerable CA or vulnerable templates. Okay, and then we will use enabled flag, so that it will only show the templates which are enabled. So basically, okay, so to our audience, let me just explain that there are two kind of attack surface here. So one attack surface is on the related to certificate authority, and the other attack surface is related to certificate templates. So in today's podcast, we are going to be looking at the attack surface on a certificate authority. So maybe for certificate template, maybe we can have some other podcast. For now, we are focused on certificate authority. So yeah, let's certify find vulnerable. Now let's give the DC IP here. 0.3, and then let me give the name of a user. So let's use David and its password. And then we will give std out. Okay. So let me just again, to our audience, let me explain then the command. So we are using certify tool, and then we are finding for vulnerable certificate authority or vulnerable certificate templates, and then we are looking for the templates which are enabled. Then we are providing the DC IP and then the username and the std out so that it will give us the output on our console. Let me run this. I hope I have not made any mistakes in the command. So yeah, so basically it's trying to ask DC about the certificate authority and certificate templates.
can you please more tell about this tool certify, like what it actually does in the background?
So actually, so basically this the security researcher Will Schroeder as well as Lee Christian, so they have developed a tool called Certify. So it's written in C# and it's a binary. So I think then many security researchers thought that maybe let's have this tool in Python as well. So they have ported that Certify tool into the Python. So this Python version is called Certify. That's why Py there. Okay. I think there is a mistake here. So let's quickly fix this. I think I might be missing something here. So Certify find vulnerable enable DC IP. So I think. Oh, okay. I think so. I'm giving the IP address wrong here. So anyway, so this is the. So actually, I'm giving the IP address of my home lab. So that's why the issue. Anyway, so it can happen. So I think this time it will be correct. Okay. So yeah, this time if you can see. Yeah. So let's quickly read through the output. Okay. So basically. So in my lab, so this is the lab that we have prepared at Redfox. So this is the same lab we provide at conferences as well as for our trainings. So in this lab, we have configured certificate authority on our domain controller. which is a child domain. Okay. But there are scenarios in real world in which we see that certificate authority is a separate server and the domain controller is a separate server. But in our case, the certificate authority is installed on a basically the child domain controller is acting as a certificate authority. Okay, that's why. So yeah, so the name of our certificate authority is Secure CA. This is the DNS name, this is the IP or the DNS name, the DNS address at which the certificate authority is. And if you see here, the web enrollment is enabled. Okay. But sometimes we will also see false positive. So there is a way to verify that. So I will show you that later. But yeah, this is how it shows that web enrollment is enabled and the request disposition is set to issue. And if you go down, it will also show you, the tool will also show you that, hey, the web enrollment is enabled and the request disposition is set to issue and it is vulnerable to ESC8, which is escalation technique 8. Okay. But we can verify this as well. Okay. How we can verify this? Okay. So what we will do, we will go to a IP address. No, not the IP address. We will go to the web enrollment address. Okay. So it's at the CA IP address, which is again 10.11 1500, and it's present at this endpoint, which is cert srv / cert fnsh.asp. Okay. If you see, it is asking for authentication. And what type of authentication it is asking? So let's quickly see that as well. Let me go to the, and if you go to the network, let me just cancel this thing. Okay. So if we see here, if we see this request that we are sending, okay, and in the response we are sending a request, okay, to this endpoint, and in the response if we see that there is it is asking us for NTLM authentication. So that's why we know that this web enrollment service requires NTLM authentication. Okay. So that's how we can enumerate. So you can enumerate using this tool or you can enumerate manually by going to this endpoint and checking what type of authentication it requires. Okay. So yeah, so we now know that this certificate authority is vulnerable, okay, to this NTLM relay attack. Okay. So now we will set up a relay. So we can again use certify a tool and use the relay module. Okay. Now let's give the target, which is the certificate authority. 100, and then we will ask, we will use for flag, we can use domain controller. Okay. So I hope the command is clear. Okay. Now what we are going to do, using the petit potom tool, we are going to coerce authentication from a domain controller, and this certified tool will take that NTLM authentication of the domain controller, and then it will ask the certificate authority to get the template of the domain controller. Okay. And since we have the correct NTLM authentication of the domain controller, we will get a certificate. Okay. Basically we are fooling the certificate authority that, hey, we are the domain controller. Okay. So let's see. Python petit potom is the name of the tool. Okay. Now let's yeah. Now we will give username. Let's give David, and password. It's one @ and then we will give the attacker IP, which is present at 10, this Kali machine, which is present at 10.11.15.50, and then we will give the IP of the domain controller, which is present at 10.11.15.40. Okay, so let me explain this command again. So we are using petit potom tool, which is a Python script, and then we are providing the username and password. So when this petit potom vulnerability come into picture, I think it was in 2021. At that time, it was unauthenticated, meaning that even without any user credential, we can coerce a domain controller. So any unauthenticated user can just coerce domain controller and get the certificate. So but Microsoft patched this vulnerability, but we see there are many environments in which it is not patched. And an attacker without any authentication, without any user credential, they can exploit it and gain access to the domain controller certificate, and there the game is over. They basically they own the domain then. Okay, but this time this is a patched environment. That's why we are giving the credentials. So this credential maybe you can attacker can get via password spray attack, or maybe fish a user and get the credentials. Okay, and then we are giving the IP address of the attacker machine, where on which we have already the relay setup here. Okay, and then we are coercing the domain controller, which is 10.11.15.40 IP address. Okay, so now what this tool is doing. So before that, let me just run this as well. Now the relay is ready. Okay, so if you see, it's targeting the same endpoint that I just went to. Okay, and now I will run this, and then we will see in detail how it's happening. So let me just enter it. If you see, okay, now we have the certificate of the domain controller. But for our audience, let me just go in deep detail, and let me tell how step by step it is happening. Okay. So before going to the exploitation part, so let's read through the output of this petit bottom. Okay, what's it doing? So whatever I have explained is doing the same thing. So first, it will bind to this named pipe, which is LSA RPC, which is a local subsystem authority. Basically, this is used to authenticate and connect to the system. That's why we are using the username password here, so that we can authenticate to the domain. Okay. Then we are binding to this. Basically, this is a UUID for EFS RPC protocol. Okay. So now we are binding to this protocol so that we can trigger those vulnerable functions that we just talked about. So if you see, we have successfully bound to this EFS RPC protocol, or interface you can call, and then we are basically triggering this EFS RPC open file raw function. So we are basically calling that function and telling that, hey, I have some data, can you please encrypt that data? And when the system tries to encrypt that, basically when the server tries to access that data, at that time we can ask for their authentication. But if we see, in this case, it is patched. So this function is already patched by Microsoft. But as pen tester, we don't stop there. When something is patched, we will find some another way. So that's why we have another function. So if you see this OK using unpatched function. So there is another function which is EFS RPC encryption file SRV. So now we will ask this function to again and do some encryption operation on our data, and then we will just send the authentication. Okay, so that's what is happening here. Or if you want to go more detail, we will just go through the code of petit bottom. Let's go through there. Okay, same thing I explained, same thing is happening there. Maybe. Okay.
So basically, we are just trying to tell the domain controller that we are the service, like using that RPC to connect us, and we will then relay that the authenticated request to that CA. Okay.
Correct. So that same thing. So I think, let me just scroll down. So yeah, so this is the coerce function, and we will go through this side by side. Okay. So let's see this. If you see, first trying to connect to this pipe, which is LSA RPC. Same thing here. It's trying to connect to this RPC pipe. I think it's here, binding to this pipe. Let me see where. Something went wrong. Yeah, if you see here. So here we are trying to first authenticate to the LSA RPC service. And if you see, it's saying if the authentication is successful, it will connect. It will show connected. That's what you see here. Basically, we are binding to this, and we are getting the connected output. It means the authentication attempt is correct. Okay, I hope that's clear. And now we are binding to the EFS RPC interface using the UUID. That's what you are seeing here. We are binding to this UUID, which is the MS RPC named pipe. Okay. and then we will see successfully bound here. Okay, so that's what you see here. We are binding to the MSRPC interface, and then we will see successfully bound. Okay, and then we are calling these functions. Let's again go here. So first we are trying to open this EFS RPC open file raw function. Okay, so if you see here, if you see there is a share that we are asking that my share is present at this address. This %s is a variable for our attacker machine, and this is some fake file. Okay, so we are asking this function to basically do some encryption operation on this file, and when it will reach to us, then we will ask for the authentication, and we will have the authentication attempt. So, but if you see, if we get some error like got RPC denied, let's suppose that if the function is not patched, then we will see the attack is work. But in our case, the function is patched. That's why we see got RPC denied and using unpatched function, which is this function. Okay, the same thing if you see here, sending to this RPC, but since it is patched, we will see RPC access denied because it is patched, and then it will use another function which is EFS RPC encrypt file service SRV, and to this function again we will ask the same thing. Basically, I have some data, can you please encrypt this? So basically this EFS protocol is implemented to do encryption operation on a file which is present on a remote server. That's why we are able to abuse it. So this time this function is vulnerable, and it will send error bad path because this path is just a dummy path, right? But we have the authentication. Then we can just say that yeah, the attack worked because it is sending a bad path. It means that it reached to our path. Okay. So that's why we will see here got expected error bad network path because it's just a dummy path, because we are only asking for their authentication. We can coercing their authentication. So now it means the attack worked. So the petit bottom role ends here. Okay. Now the role comes of certificate certify relay. Okay, let's see now this in detail. Okay. So basically, let's go step by step. Okay. So we are coercing the domain controller to access this file, and it is sending us the NTLM authentication. We are taking that NTLM authentication, and then we are asking NTLM authentication mission. Then we are asking that this enrollment endpoint, hey, I want to authenticate. Okay, and then the CA using this web enrollment endpoint, it will send a NTLM challenge. As an attacker, we will take that challenge and send back to the domain controller and say that hey, if you want to access my data, can you please provide me your actual authentication attempt? But basically, the domain controller will encrypt that encrypt that challenge and will send the authentication request to us. And as an attacker, we can this certify tool it will take that NTLM this authentication attempt of the domain controller this time, and then it will send back to the HTTP web enrollment endpoint, and then ask for the certificate of the domain controller. That's why we see template domain controller mentioned in the command, and then the certificate authority via its HTTP web enrollment endpoint, it will think that a domain controller is asking for a certificate. But it cannot differentiate whether the request is coming from an attacker or from a actual domain controller, and it will give us the certificate of the domain controller. That's what we see here.